Jai Hind to all of you. My name is Vishal Jayaswal. I am assistant professor in Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Here I am going to discuss image processing subject, and today's topic is digital image processing introduction. If we talk about the digital image processing, first we know about what is digital image. If we talk about the digital image, then we can say that an image may be defined as a two-dimensional function fxy, and where x and y are spatial and plane coordinate, and the amplitude of f at any pair of coordinate x comma y is called the gray level or the intensity level at that point. Here x and y are and f are all finite or discrete quantity, then we can say that this is called a digital image. And if we talk about the digital image processing, if we process the image with the help of digital computer, then we can say that this is called digital image processing. As we said before that an image is a two-dimensional function fxy, and we represent image in two-dimensional function fxy. Here let's suppose this is an image that is of 3x3 image. Here is the some pixel value, let's suppose 7, 6, 5, 4, 3, 2, 1, 0, 7. Let's suppose this is an 3x3 image, and the intensity of the pixel is this. Here, suppose this is the location where we find out the x comma y. Here, f, that is 2 comma 2 that is equal to 3. Means here the intensity value of the pixel is 3, and the location is x and y axis values are 2 comma 2 and the value is 3. In this way, we can represent the image in the two-dimensional function fxy. If we talk about the classification broadly classified into three categories. First one is low level, middle level and high level. If we talk about the low level image processing, then we can say that our input is image and our output is also images. For example, in case of low level image processing, our example is image enhancement. And in image enhancement, there are two techniques for image enhancement, like spatial domain, image processing in spatial domain, and image enhancement in frequency domain. If we talk about the spatial domain, in a spatial domain, we work on direct manipulation on the pixel. And if we talk about the frequency domain, then we first take Fourier transform of the input image, then we process it. After that, we take inverse Fourier transform and the original enhanced image is shown. And the operation such as image negative, smoothing, all fall in this category, and these operations are the backbone of digital image processing, DIP. And if we talk about the mid-level process, in this case, our inputs are generally images, but our output are attributes that are extracted from the images, like edges, counters and identity of individual objects. And in mid-level processing, there are several tasks such as segmentation, description and classification. In segmentation, we partition an image into regions or objects, and in description of the object, in terms of feature extraction, if we extract the features from an image, then this is called the description of the image. And classify, particular, we recognize the particular object. This is through the classification or recognition algorithm. If we talk about the higher level processing, it involves making sense of ensembles of recognized object and performing the cognitive functions normally associated with vision. there are very little difference between DIP and image analysis and computer vision. If we talk about the DIP covers the both low and mid level processing till recognition. And if we talk about the image analysis, deals with knowledge extraction, and the computer vision the uses the knowledge and to take the decisions. And the ultimate goal of computer vision is to use computers to being able to make inferences and take actions. There are some fundamental steps in digital image processing by which we can process a digital image and enhance image. This is the fundamental steps by which we can enhance the image. First step is image acquisition. In image acquisition, first, if we want to process a particular image, then first we extract the image from somewhere else, like we take pictures from our digital camera or mobile phone. This is called the image acquisition process by which we can take the input image. Second is image filtering and enhancement. Basically, if we talk about the image filtering, for filtering an image, we have two things. First is an image, obvious, that is image, and second is a filter. If we want to process a particular image, then first we apply the filter mask to the input image and process the particular image. And if we talk about the enhancement, I discussed before that the enhancement is basically of two types. First is spatial domain, enhancement in spatial domain, and enhancement in frequency domain. In spatial domain, in case of spatial domain, we have an input image. This is input image. We process it and we got the output image. This is the process of spatial domain. We take the input image and apply filters that are available for the spatial domain processing, and after that we got the output image. If we talk about the frequency domain filtering or frequency domain enhancement, in this case we have an input image. Let's suppose this is our input image. Then we apply the DFT, means we take the discrete Fourier transform of the input image. Then we process the image. Then after processing, we apply IDFT, means inverse Fourier transform or inverse discrete Fourier transform. Then after that we got the output image. This is the process of frequency domain, in which we can see that we apply, before applying the processes or before applying the processing, first we take the discrete Fourier transform of the input image, and before showing the output image we take the inverse discrete Fourier transformation. These two processes are totally different from each other. Next is image restoration. If we talk about the image restoration, means we want to restore our original image. Means if we want to restore original image, means we have a input image and first we degrade the image quality. by applying the some noise. In case of image restoration, we have an input image. First we have an input image. This is an input image. We apply some noise, means we have to add some noise to degrade the quality of the input image. First we degrade the for degrading the quality of input image, we apply the some noise to the input image. After that we apply the filter, to get the estimated output image. Here we choose the word estimated, means in this process we can see that first we have an input image. We degrade the quality of the input image by adding noise. After that we are going to apply multiple filters, and after applying the multiple filters we got the estimated output image. Means we cannot totally recover the input image. We can recover 99.9% image or 98% image. So here we can use the word estimated for the output image. In restoration process, in this way we can process the images. If we talk about the next, that is color image processing. In color image processing we have an RGB model. We have RGB model, means red, green and blue. These are the primary colors by which we can form these three colors, so that we can say it primary colors. In color image processing we have an RGB model, HSI model, that is hue, saturation and intensity. These are the HSI model, and last is that is a CMY model. That is CMY means cyan, magenta and yellow model. These color study is under the part of the color image processing, in which we can tell about RGB model, HSI model and CMY model. If we talk about the wavelets and multi-resolution processing, in which we can see that the multi-resolution of the input image, by which we can multiple resolution images can be formed by applying 224 cross 224, let's suppose 224 cross 224. Then we can further apply, let's suppose 56 cross 56. These are the resolution of the particular image. And in image compression, if you want to an image, and after enhancing in image, if you want to send an image from one place to another place, then the requirement of image compression. In image compression we have multiple techniques like run length encoding, run length, Huffman encoding. These topics are discussed in this image compression. Then morphological processing. In case of morphological processing, we talk about the translation, reflection, dilation, erosion, and basically dilation and erosion are the basic concept of the morphological image processing. and the most concept of morphological image processing is applies on the binary images, basically 0 and 1. And here in this morphological processing we also learn the concept of heterogeneous transformation, that is very important for the subject. And in image segmentation, in case of image segmentation, there are some topics like region approach, boundary approach, and edge approach. Basically, in image segmentation, we partition an image into multiple parts, for which we have an approach like region approach, boundary approach, and edge approach. And in region, if you talk about the region approach, in region approach there are 3 algorithms, that is of region growing, region splitting, and region merging. These are the algorithms for region approach. And if you talk about the image representation and description, in this case we have basically for image representation we use the chain code to represent the image, and we have 4 chain code or 8 chain code. If we talk about the 4 chain code means we have to keep in mind this direction means 0, 1, 2 and 3. This is for 4 chain code, and this is for 8 chain code, means 0, 1, 2, 3, 4, 5, 6 and 7. This is for 8 chain code. These are the symbol are used for taking chain code from a particular image. For object recognition, if we want to recognize a particular object, then we have to classify the image for the recognition. These are the key factors in digital image processing that we already discussed. That is, first we have a problem domain, means we have an input image, then we acquire image from acquisition process, then we apply the enhancement techniques. After that we restore the image, then apply the morphological processing, then segmentation, then representation and description, then object recognition. These are the main process of the digital image processing. Let's talk about the fundamental steps in digital image processing. We already discussed these points: restoration, color image processing, morphological. Then talk about the components of image processing system. If we talk about the components, here for image processing we require certain components to process a particular image. First we have to image sensor or digitizer, by which we can take the pictures or take the input image. Second is specialized image processing hardware or computer. We want some particular image processing hardware and or computer for the processing of the digital image. And third point is image processing software. We have also image processing software to process a particular image like CorelDRAW, and we have mass storage for storing our digital image, and image display and hard copy devices, means we have to see our images. We want a monitor, and if we want to take a printout, then we have a printer. Then image transmission system means if we want to transmit an image from one place to another place, then we have a network. This is the particular architecture of image component of digital image processing. Here there is a network. This is the problem domain. Here we can see that image sensors take the problem domain. After that, this is supplied to the specialized image processing hardware, and then after this goes to the computer, and in computer the lots of things are connected like image display device, mass storage, and image processing software, and hard copy means printer. These are the connection of the computer, and the computer are connected to the network for the transmitting our processed image. If we talk about the image sensor or digitizer, image sensor is a physical device that is sensitive to a light radiated by the object and wish to image. What is the digital image functions can be categorized as domain and range both are continuous, and discrete if domains is discrete, and the digital if domains and range are both are discrete, and the domain range in case of digital image processing is discrete and achieved through sampling and quantization. Basically, a continuous function of two variables fx, y, where x and y are the coordinate and f is the amplitude. Then image function's value correspond to the brightness at that point, and the fx, y must be non-zero and finite. Here we can see that our image is a fx, y whose range belongs between 0 to infinity, means the value of f and x, y should be finite. And in which scenario this fx, y is formed? For this, there is a image formation model equation is fx, y equal to ixy into rxy, and here ixy is the illumination component and rxy is the reflectance component. And if we talk about the ixy is the amount of source illumination incident on the scene being viewed, and the range of the ixy is between 0 to infinity. And rxy, if we talk about the rxy is the amount of illumination reflected by the object in the scene, and the range of the rxy means reflectance component is between 0 to 1. Here to 0 means, what do you mean by 0? 0 means total absorption, and 1 means total reflectance, and the value of rxy is in between 0 to 1. If we talk about the sampling and quantization, if we want to sample or quantize a particular image, then we can say that if we want to digitize the coordinate value, what is the coordinate value? Means x comma y, these are the coordinate value. If we digitize x comma y, that process is called the sampling. And if we digitize the amplitude value, what is the value of amplitude? That is f. If we digitize f, or we can say that amplitude value is called the quantization. This is the diagram for the sampling and quantization. If we are going to discuss the types of images, there are 3 types of images in digital image processing. First is binary image, second is grayscale image, and third is color image. If we talk about the binary image, in binary image there are only two levels, or we can say that there are only two colors, that is black and white. Means 0 means black and 1 means white. In this binary image only two pixels are shown, that is 0 and 1. In case of grayscale image, in case of grayscale image, a grayscale image has 256 gray levels, means range of grayscale image is 0 to 255, and a pixel is represented by 8 bits or a byte. Here we can say that in grayscale image, if we talk about the binary image, this is the case of binary image. Here we can say that every pixel either 0 or 1 in case of binary image. This is the case of binary image, and in here this is the case of grayscale image, where the pixel value should be in between 0 to 255. Let's suppose this is 250, this is 240, this is 10, this is 20, this is 150, this is 160, this is 190, this is 224, this is 220. This is a grayscale image, and this pixel value, or we can say that this intensity, if we want to store the particular pixel value, then we have to 8 bits or 8 byte. And in case of color image, basically in color image there are three colors are present, that is RGB, that is red, green and blue. And in color image processing there are three components are present, that is red component, green component and blue component, and each component taking the storage of 8 bit. So in color image there are only 24 bits required a particular pixel of a color image, and in color image total 16.7 million colors are present in color image. Thank you for the lecture.